Video we're going to talk about how we can check if a relationship is a function. We know that functions can help us predict things, right? So in this case, let's look first at the tables. Okay? When we look at the tables, we're going to look at the following. If I have an input and it gives me only one output, so I have a 0 and 0 gives me 8. Do I have another 0 here? No. So 0 always gives me 8. That's good. Then this relationship still seems to be a function. Now I have another input 2, and that input gives me 1 as an negative 1 as an output. Does an input of 2 give me anything different from negative 1? No. Here, input of 2 again gives me an output of negative 1. So this is still a function. Let's look at 5. An input of 5 gives me an output of 4. Can an input of 5 give me a different output not equal to 4? No. Therefore, here, all these inputs have only one output. All inputs have only one output. So if I choose an input, I can always predict the output. I can always predict the output. Therefore, yes, this table represents a function. Now let's look at the second table over here. In the second table, we're going to look at every input and see if it has only one output. An input of negative 4 has only one output, which is negative 4. Input of negative 2 has only one output, which is output of negative 2. However, input of 1 gives me two different outputs. I can either get a 0 or I can get a 1. I cannot predict which one I'm going to get. I cannot predict the output. If I cannot predict the output, that means that this table does not represent a function. It's not a function. How about graphs? Sometimes we're given graphs and you're going to have the question, is this a function? Okay, is this graph representing a function? And how will you know? Here's every input. Let's take the input negative 4. I'm going to draw a vertical line and I'm going to check how many times that vertical line crosses my graph. It crosses it one time. So that input corresponds only with one output. Let's draw another line here. It's negative 7. How many times does that input of negative 7 cross the graph? Only one time. So an input of negative 7 has only one output. What about an input of 2? If I have an input of 2, an x value equal to 2, right? It crosses the graph only in one point. Therefore, an input of 2 gives me only an output of negative 6, nothing else, just an output of negative 6. So if I put 2 in my function, I always know I'm going to get negative 6. Therefore, this is called the vertical line test. Vertical line test. It's called the vertical line test because I'm drawing vertical lines through the graph and I'm seeing how many points of intersection do those lines have with the graph. If they have only one point of intersection, that means for every input there's only one output. Okay, so yes, this will be a function because every input has only one output. Let's do the vertical line test over here. I'm going to draw a vertical line at x equals negative 2. X equals negative 2, and I'm drawing my vertical line. Now, I'm touching the graph in two places. I'm touching the graph at sort of like almost, this is something like 4 point, let's say 4.5. And I'm touching the graph at negative 4.5. So an input of negative 2, if I make a table, gives me an output of 4.5. And it also, negative 2, gives me an output of negative 4.5. Can I predict which output I'm going to get? No, I cannot. Therefore, this is not a function based on the vertical line test. So for tables, we need to just look if we have the same input pointing to two different outputs. This will give us no functions. And for graphs, we have to draw vertical lines and see how many times they intersect the graph.